All right, this is section 4.7, inverse trigonometric functions. So we've already talked about inverse trig before. If sine of theta is 1/2, then remember we take theta equals sine inverse of 1/2. We type that in our calculator, second sine of 0.5. It's going to give me theta is about 0.524 because I'm in radians. If cosine of theta is negative 0.248, remember we find theta by taking the cosine inverse of negative 0.248. Second cosine, negative 0.248. I get about 1.821 radians. We've done that before with degrees mostly, but radians works exactly the same. But we're talking about inverse functions. Remember that there are two tests to tell that a function has an inverse. The vertical line test, that tests to see if it's even a function, and the horizontal line test. Now the question here is, do any of the trig functions pass both of those tests? And the answer is no. They all pass the vertical line test, but none of them pass the horizontal line test because they repeat. So to find the inverses of the trig functions, we have to limit their domains so that the functions are indeed one-to-one. They pass the vertical and horizontal line tests. So when we limit the domains, if we think about the graphs we drew, we need to limit the domains so that we have a full cycle and the function is one-to-one. So let me draw a rough sketch for sine. Sine starts at 0, pi, 2 pi, and it goes up, down, back up, right? There's my really good drawing. I want a full cycle, but I can't have it cross itself. I need it to be lowest to highest. My lowest point to highest point can be cut out right there. I have this portion of the graph that I just repeat. And I may not repeat it exactly, I reflect it here. But it's just those two pieces over and over and over again. So we're going from the lowest to highest, which is negative pi over 2, to positive pi over 2. We'll do a similar thing with cosine. Cosine, remember, starts at its maximum, though, and goes down, back up at 2 pi. There's pi. And we do the same thing over here. Really good drawing, I know. All right, we want to go bottom to top. But instead of going pi to 2 pi, we can just start at 0 and just cut it off at pi. So then we have a full cycle. Top to bottom, every possible y value one time. So cosine is actually 0 to pi. And then we'll think about tangent. Tangent, remember, is the wonky one. It looks like this, right? Pretend my arrows are there. One full cycle of tangent is nice because it's bounded on either side. So like sine, we're going to go negative pi over 2 to pi over 2. But be careful on these. Sine and cosine exist at their boundaries. Tangent does not. So sine's new domain is going to be negative pi over 2 to positive pi over 2 included. Cosine will be 0 to pi included. Tangent will be negative pi over 2 to pi over 2 not included. All right. So, reminder, what is an inverse? What does the inverse of a function do to the function? It undoes it. It does the exact opposite. If a trig function takes an angle and gives a ratio of sides of a triangle, The inverse takes the ratio of sides and gives us the angle. Remember that the answer to an inverse trig function is an angle. So, an inverse trig function represents an angle. The inverse sine or cosine or tangent of x is the angle whose sine or cosine or tangent is x. So the answer is an angle. So the inverse sine function. Generally, we denote the inverse sine function as y equals arc sine of x instead of sine inverse of x in order to avoid the confusion of a sine raised to a -1 power. I don't know why there's that extra space in there. It's fine. So y equals arc sine of x if and only if the sine of y equals x. X has to be between -1 and 1. Arc sine can only work from -1 to 1. And our y value will be between -pi/2 to +pi/2. The domain of arc sine is -1 to 1. The range is -pi/2 to +pi/2. Inverse cosine, very similar. We use arc cosine if and only if the cosine of y equals x, where x is between negative and +1 again. This time y is between 0 and pi. The domain of arc cosine is -1 to 1. The range is 0 to pi. And inverse tangent, we like to call it arctangent. Y equals the arctangent of x if and only if the tangent of y was x. This time we can plug in any number. X can be negative to positive infinity. And y, though, will be between -pi/2 and pi/2, not included. So the domain is all real numbers. The range is negative to positive pi/2. And some graphs to help you see that portion of it. This is inverse sine, arc cosine, and arc tangent. Notice they look a little different than their counterparts, but they are reflected over the line y equals x. So let's find our exact value. The arc sine of -1/2. I want what angle has a sine. So the sine of what angle equals -1/2. But we have to keep in mind it has to be between -pi/2 and +pi/2. That's the fourth and first quadrants of the unit circle, but the fourth quadrant, all the angles become the negative versions, all right? It's like -pi/6, -pi/4, -pi/3, -pi/2. So the sine is -pi/2 at -pi/6, or sorry, -1/2 at -pi/6. So there's our answer. The sine inverse of √3/2. √3/2 is more than 1. No, it's not. Just kidding. Where is the sine √3/2? Well, it's positive, so it's in the first quadrant. And that is at pi/3. So our answer is pi/3. Here we go. Arc sine of 2. 2 is more than 1, which means it doesn't have an arc sine of 2. That is undefined. There is no arc sine of 2. All right, let's try some arc cosine. Arc cosine of the √2/2. All right, think about where is cosine √2/2 between 0 and pi. Well, that's at pi/4. Arc cosine of -1. Well, cosine is -1 at pi, so there we go. Arc tangent of 0. Where's tangent 0? Well, that's at 0 radians or pi radians. But arc tangent only goes from -pi/2 to pi/2. So our answer is 0. An arc tangent of -1. Arc tangent is -1. Okay, arc tangent only exists in fourth and first quadrant. That's pi/4, but a negative pi/4. So let's use our calculator to get these to 3 decimal places. All right, to get an arc tangent, we just hit second tangent of that number, 8.45, -1.453. Same thing with arc sine, second sine of 0.2447, that's 0.247. And arc cosine of 2, second cosine of 2, error domain. I cannot put in an arc cosine of 2, undefined. The range of arc cosine is only -1 to +1. All right, so then we'll talk compositions of functions. So a reminder that f of its inverse simplifies to x. And the inverse of f also equals x. If I plug a function into its inverse or vice versa, it simplifies to just x. So if x is between -1 and 1, and y is between -π/2 and π/2, then sine of arcsine of x equals x. And arcsine of sine of y equals y. Basically, if my x and my y are in those ranges, then they simplify to each other. Same thing with cosine. If x is between -1 and 1 and y is between 0 and pi, cosine and arccosine cancel each other out. And if y is between -π/2 and +π/2, tangent and arctangent cancel each other out. So let's find some values. Tangent of arctangent of -5. Tangent and arctangent are special because tangent can give us any value between negative and positive infinity. So the arctangent of -5 is just some angle that has a tangent of -5. The tangent of that is just going to give us -5. If it had been arctangent of tangent, then we'd have to be a little more concerned. Arcsine of the sine of 5π/3. This is where we start inside and work our way out. So first question is, what's the sine of 5π/3? It's -√3/2. So now I want the arcsine of that. Well, my answer is not 5π/3 because 5π/3 is not in the domain or the range of arcsine. Arcsine can only give me answers between -π/2 and +π/2. So essentially, I'm going to get the coterminal angle with 5π/3, which is -π/3 for my answer. And the cosine of the inverse cosine of pi. All right, inverse cosine of pi. Inverse cosine of pi is undefined. No angle has a cosine of pi. Be careful, because your brain probably said, oh, the cosine of pi is -1. But be careful, it's inverse cosine. All right, these ones we're going to draw some triangles for. So, tangent of the arccosine of 2/3. The nice thing is, if they're both positive, then our angle's in the first quadrant. Arccosine of 2/3. That means this angle has a cosine of 2/3, which means adjacent over hypotenuse. Tangent is opposite over adjacent, but I can use Pythagorean theorem really quick to find that this is the square root of 5. So my tangent is the square root of 5 over 2, and there's my answer. Cosine of arcsine of -3/5. This is where we have to be careful because arcsine only exists in the first and fourth quadrants. So if it's negative, that must be the fourth quadrant. So that's the angle I'm looking at. If the arcsine is of -3/5, so this opposite is -3, hypotenuse is 5, I can get the adjacent, it's going to be 4. The cosine of that angle is 4/5. So there we go. All right, these are some challenge problems. We're going to write these as an algebraic expression. My hint is drawing a triangle. So arccosine of 3x, and the sine of that. X is between 0 and 1/3. So that means x is positive. We'll go there. Sine of arccosine of 3x. Well, cosine is adjacent over hypotenuse, so the adjacent is 3x, the hypotenuse is 1. The opposite side here is going to be the square root of 1 minus 9x squared. So the sine is opposite over adjacent. That is the square root of 1 minus 9x squared. Cotangent of the arccosine of 3x. Well, we're dealing with the same triangle. So cotangent is adjacent over opposite, which is 3x over the square root of 1 minus 9x squared. And since that's a bit more intense than our normal square roots, we can allow the square root to be in the bottom. All right, exact values without a calculator. Sine inverse of 1/2. Well, that's going to be in the first quadrant. What angle has a sine of a half? That's pi over 6. And now I want the cosine of pi over 6, which is square root 3 over 2. Sine inverse of the cosine of pi over 4. Cosine of pi over 4 is square root 2 over 2. So I want sine inverse of that. Well, it's going to be in the first quadrant, so that is pi over 4 again. Sine of tangent inverse of -1. Tangent inverse of -1 is negative pi over 4. I want the sine of negative pi over 4. That's negative square root 2 over 2. All right, now we're getting crazy. Start with the inside. Cosine inverse of a half. Cosine inverse of a half is pi over 3. Then we multiply it by 2. So I want the sine of 2 pi over 3, which is square root 3 over 2. Arc sine of the cosine of pi over 3. The cosine of pi over 3 is 1/2. So I want arc sine of 1/2, which is going to be pi over 6. Arctangent of the cosine of pi. The cosine of pi is -1. Arctangent of -1, that's the fourth quadrant, so it's negative pi over 4. All right, this one is going to require a triangle. Arctangent of a negative means that it's in the fourth quadrant. Tangent is opposite over adjacent. That 8 gets that negative because it's downward. And use Pythagorean theorem to find that missing side. It is 17. Now I want the cosine of that angle theta I drew. The cosine's adjacent over hypotenuse is 15 over 17. All right, same story, different problem. Tangent inverse, it's a positive number, so it's in the first quadrant. Tangent is opposite over adjacent. I can find that third side using quadratic formula, not quadratic formula, wow, Pythagorean theorem, there we go. It's 13. The sine of that angle then is opposite over hypotenuse, which is 12 over 13. All right, this time cosine is negative. Cosine inverse is only defined in first and second quadrants. Cosine's negative in the second quadrant. So we're actually over here. This is -3 over 7. Pythagorean theorem to find my missing side, and it's not a whole number. All right. It is the square root of 40, which is 2 square root 10. The sine of that angle theta is 2 square root 10 over 7. All right, cosine of sine inverse of -2/11. Sine inverse of negative means we're in the fourth quadrant. And the sine, so opposite over hypotenuse, that 2 and the opposite gets the negative. Quadratic, no, wow, why do I keep saying that? I'm sorry. Pythagorean theorem to find the missing side. We have the square root of 117, not pretty. And the cosine of that angle then is the square root of 117 over 11. But wait, 117 actually can be simplified to 3 square root 13. That's a sneaky one. All right, now the length of the shadow of a building. The building is 34.09 meters tall. All right, building. 34.09 meters tall. And the shadow is 37.62. Now, last I checked my shadows on the ground, 37.62. Find the angle of elevation of the sun. There we go. Well, I would find that angle using a tangent. The tangent of that angle equals opposite over hypotenuse. So 34.09 over 37.62. Remember, to get an angle out of a tangent, we use inverse tangent or arctangent. 34.09 over 37.62. Now, generally speaking, when we switch to a word problem, angle of elevation and angle of depression, we use degrees. So I switch over to degrees in my calculator. An inverse tangent of 34.09 divided by 37.62. My angle is about 42.182 degrees. And for the construction of a house, a 16-foot by 6-foot wooden frame is made. Find the angle that the diagonal beam makes with the base of the frame. And I'm giving you this picture because the wording's a little wonky. So if it's 16 at the top, it's also 16 at the bottom. And look at that, I got a triangle. I know the tangent of that angle theta is 6/16, which means that theta equals the inverse tangent of 6/16. Notice that I don't waste any time simplifying my fraction because I'm just going to type it in my calculator anyway. So theta is 20.556 degrees. All right, you're going to have an assignment out of the textbook now.